In this video, we're going to talk about solving and graphing linear inequalities. So first, as a reminder, we remember that an inequality can be solved in the same general manner that we've used to solve an equation. Or in other words, we're going to solve using the backwards order of operations. So remember that when we simplified, we followed the order of operations by first simplifying in parentheses, then exponents, then multiplication, division, and then addition and subtraction. However, now that we're solving an inequality, I'm simply going to start by undoing addition and subtraction, then undoing division and multiplication, and undoing exponent, and then undoing the parentheses. There is a key difference, however, and this key difference is going to occur when we multiply or divide by a specific type of value. And the value that we're talking about here is a negative value. So when we multiply or when we divide by a negative, there is a key change, and this is that we're going to switch the inequality sign. So we must switch the inequality sign. Now what this means is that if I have an equation with a greater than sign and I multiply or divide by a negative, it's going to become a less than sign, and then vice versa. If we multiply or divide an inequality that has a less than sign, we have to switch it into a greater than sign. But otherwise, besides this, we're essentially going to be solving these inequalities the same method that we've been using to solve equations. So let's look at a few examples of these problems. So here's our first inequality. We're asked to solve and graph. And I notice that I have all these operations over here with the x. Now I know this is an inequality because instead of something that is equal, I see that I have this greater than symbol right here. So we want to go ahead and isolate the x. And there's a couple things to do. But I always think that whenever we have parentheses, it's not a bad idea to start by simply distributing across the parentheses. This is going to make combining like terms a little bit easier, and this is going to make solving these inequalities a little bit easier. So if we distribute, I'm going to be left with negative 3x minus 12, when I distribute, plus 2 is greater than 8. So at this point, I've distributed, we have a simpler equation. Now I notice that we have a couple of like terms here, though. And if we zoom right in, I notice that the negative 12 and the 2, these are both constant terms that can be combined. And in fact, we can combine these into a negative 3x, but then negative 12 and the 2 combine to negative 10 greater than 8. So these first two steps, all I did was distribute and then combine like terms. Next, we now notice, well, I need to solve for the x. So I'm going to undo in the opposite of the order of operations. So I have two different operations here, multiplication, and then I have subtraction. I need to undo the subtraction first by the opposite order of operations. So the first thing I'm actually going to do then is add 10 to both sides. And this is going to give me the new equation, or inequality rather, negative 3x is greater than 18. And at this point, we've almost solved for x. I'm almost done. I need to undo the multiplication by negative 3, or in other words, I need to divide both sides by a negative 3. And this goes directly back to what we just talked about. Because I am dividing by a negative value here, yes, I know that negative 3x divided by negative 3, this is going to simply give me, I'll write it big over here, just x. And I know that 18 divided by negative 3 is a negative 6. But because I'm dividing by a negative, I need to change the direction of the inequality sign from a greater than sign to a less than sign. So in fact, I'm actually going to be graphing when x is less than negative 6. And again, this is less than a couple reasons. It's pointing to the lesser value, so x is the lesser value. Or in other words, sometimes we remind ourselves that this kind of looks like an L when we draw the inequality sign a little bit cockeyed, L standing for less than. Either way, though, we recognize that this means that I have the statement x is less than negative 6. So x is less than negative 6. So first key thing I notice here is I'm going to go to negative 6. Because it's just less than and not less than or equal to, I'm going to put an open circle at the negative 6 right here. And the less than implies that we're shading to the left, which means negative 7, negative 8, negative 9, negative 10, and then everything else to the left is going to be less than negative 6. So this would be our shaded in solution, right, where we recognize that x is less than negative 6. This is our solved inequality that we're graphing. Next example, I'm again asked to solve and graph this inequality. Unlike before, I really don't have the opportunity here to distribute the negative 2 across parentheses because there really are no parentheses, even though sometimes we talked about imagining that there was an implied set of parentheses on the top. The negative 2 is not being multiplied across those. However, because I'm dividing this entire set of parentheses by the negative 2, what we can do is do the inverse operation of the division by the negative 2, which is actually to multiply by negative 2. So if I multiply both sides here by negative 2, or in other words, negative 2 over 1, so I'm doing that inverse operation to both sides here, what we notice is that these inverse operations are going to cancel. In other words, the negative 2 and the negative 2 are going to divide to 1, and I am just going to be left with the 4x plus 6, so 4x plus 6 on the left-hand side, and then the right-hand side, the negative 12. But we have to be careful here again. I just did multiplication by a negative sign, and this is important, right? If I do multiplication by a negative, this inequality sign here, this less than or equal to, is going to have to switch, or in other words, I now actually have greater than or equal to because we just multiplied, or in other words, did a negative operation to both sides. So now at this point, we are all set to just simply continue solving this problem. So the next thing I'm going to do is subtract 6 from both sides. Again, I had two operations, multiplication and addition. By inverse order of operations, the first thing I should undo is the addition by subtracting 6. So notice that this gives me that 4x is greater than or equal to negative 18. And some of you might be saying, well, that's a negative 6, that's a negative number. Shouldn't we be changing the sign? And the answer is no. Only when we multiply or divide by a negative do we change the sign. So then last thing I need to do here is do the inverse of multiplication, which is division. So if I divide by 4, I'm going to end up with x is greater than or equal to negative 18 over 4. Or in other words, x is greater than or equal to, if I make 18 over 4 a decimal, that's about negative 4.5. Now if we look at the inequality symbol, we can go ahead and graph this now. Again, now that I'm pointing, the inequality is pointing to the right to the negative 4.5, that implies that this is really saying that x is greater than, so x is greater than negative 4.5. So greater than negative 4.5. And a couple things we want to be careful about here. Because of this or equal to sign, this little line under the greater than symbol, this means that when I graph the inequality, first of all, negative 4.5 is right between negative 5 and negative 4. I'm going to put a filled in circle here, implying that not only is negative 4.5 the boundary, but it's also part of the solution because of that or equal to. Right? So not only is this greater than negative 4.5, we can even add in then a or equal to. So x is greater than or equal to negative 4.5. Now, the greater than implies that instead of shading to the left, we're now going to be shading to the right here. So that means everything to the right, such as -3, -1, 0, and then obviously all the positive numbers should be greater than or equal to the -4.5. So if I just keep shading in, that means everything to the right and even above 10 are going to be greater than -4.5. And there's our solution set. So the next equation, we're asked to solve and graph again. I do notice that we do have some parentheses here. I notice this p plus 3 in parentheses that we can distribute across. So if we start with this, if I distribute the -2 across the parentheses, I notice that this is going to give me, I still have the 4p. -2 times p is a -2p. -2 times a positive 3 is a -6. And then we still have the rest of the equation less than 6. So now I'm looking to simplify. I notice that I have two like terms here. I can highlight them right here, the 4p and the -2p. Those are going to combine into a positive 2p minus 6, which is then less than 6. Again, I know this is a less than sign because it's pointing to the left. So now I need to solve for the p. I have the p that's being multiplied by 2 and subtracted by 6. So by opposite order of operations, I need to undo the subtraction first by adding 6 to both sides. And this is going to leave me then with 2p is less than a positive 12. Now every time we do an operation, we want to ask, do I have to change the inequality sign? The answer here is no. I didn't multiply or divide by a negative. In fact, I actually added by a positive value. So addition and subtraction, those are both okay. And even multiplying and dividing by positive values are okay. Only when we multiply or divide by a negative do we have to switch that inequality sign. So now if we come over to the right here to get a little bit more room, I had this equation which I'll rewrite. 2p is less than 12. The only thing I have to do now to get p by itself or to solve is to undo that multiplication, which means I need to divide. Right, the inverse of multiplication is division. And if I divide both sides by 2, I get p and I get 6. Do we need to change the inequality sign? The answer is no, because I divided by a positive value, not a negative value. So I can see that this is going to be p is less than 6 as our final inequality. And we can write this out if we want, again, just for clarification. Because the arrow here is pointing to the left, it's pointing to the lesser number, or in other words, it looks like an L, another way of thinking about it. This is saying that p, so p is less than 6. And there's no bar below the inequality sign, so this is not less than or equal to, it's simply less than 6. So I can identify on the number line then for our graph the number 6. Since it's not or equal to, I'm going to leave an open circle there, and then I'm going to shade off to the left, because everything to the left, looks like 2, 3, all these other numbers, these are all less than the 6 that we have been given, including all these negative numbers. These are also all less than, so these are all part of our solution, all the way down to negative infinity, just like this. So in the final example, we got a lot of terms now, but don't let a problem like this intimidate you. We still just want to take it step by step. I noticed a lot of parentheses here. In fact, I have 1, 2, 3, 4 sets of parentheses, but all we really need to do is distribute across all these parentheses, and then we're just going to have a bunch of like terms to combine. So first, I'm going to distribute the 2, and this is going to give me 8p plus 6. Then I'm going to go ahead and distribute the -3. There's only one term inside the 3p. Notice how I don't have to distribute to the 3 and the p because they are not being added, but instead are connected by multiplication. So that's going to give us -9p. Still have that inequality sign, and since it's pointed to the right, it looks like a greater than, and that bar underneath means greater than or equal to. I can now distribute the 3 across the parentheses. So 3 times 4, that's going to give me 12. and 3 times the negative p is negative 3p. And then one more set of parentheses distributed across. I need to multiply this negative 2 across. So negative 2 times 3 is a negative 6. And then negative 2 times a negative 3, negative times a negative, is actually a positive 6p. So now on each side I have a couple like terms that we can combine. And if we zoom in here, I have 8p and then a negative 9p. Notice that these are both on the same side of the inequality, so we are just simply combining those. That's going to combine into a 8p minus 9p, a negative p, and then the plus 6. We still have our inequality sign. Notice I haven't really done anything to both sides of the operation yet. I'm just distributing and then combining like terms. On the right hand side of the operation, got a couple terms we can combine. First I have the 12 and the negative 6, or in other words 12 minus 6. That's just going to combine together to a positive 6. And then finally it looks like we have one more set of operations that can be combined here. We have this negative 3p and the positive 6p. And that's going to combine to a positive 3p. So now that I've distributed and simplified both sides of the equation, we do need to somehow try to get, first of all, both these p's on the same side, and then combine them into one p term and then simplify. So first, if I want to bring both p's to the same side, I think if I add p both to the left and the right hand side of this inequality, this will give me this new inequality. And negative p plus p, those are simply going to cancel. And this is going to leave me then with 6 greater than or equal to 6 plus a 4p. So again, the quick question here is, now, do I need to switch the inequality sign? The answer is no. I didn't multiply or divide by negative. I just added a positive p. So this is fine. So let's make a little bit of a section over here where you can finish this problem. So if I bring this over to finish, next thing I would do is subtract 6 from both sides. I'm going to try to get that 4p by itself. So if I subtract 6 from both sides of the inequality, this is essentially just going to leave me with 0 is greater than or equal to 4p. Again, do I need to change the inequality? There's a negative 6, but the answer is no. I wasn't dividing or multiplying by the negative 6, simply subtracting. So I don't need to change that inequality sign. And then the last thing I need to do in order to finish solving, the inverse of multiplication is the division by 4. And 0 divided by 4, I end up with this final equation. 0 is greater than or equal to p. And you might be noticing, well, this is a little weird to read. This is saying 0 is greater than or equal to p. We're always used to writing the variable on the left-hand side, and that's okay. If you want, you can even rewrite this as p greater than or, less than or equal to 0. So notice how as long as the arrow is still pointing to the same object, I can change the order. So here the arrow is pointing at the p, and again, as long as the arrow is still pointing at the p, in other words, implying that p is less than or equal to 0, that's the same thing as saying that 0 is greater than or equal to p. So now in terms of graphing our solution, all I have to do is identify 0. Now I'm going to fill in the circle because it is greater than or equal to. Right? Remember that little bar underneath here, that implies that it's or equal to. And since it is pointing to the left, pointing to the p, this is a less than, so I should be shading to the left. And it makes sense that all these negative numbers are less than or equal to 0. So my final solution is going to look just like this. So at this point, there are 2 on-your-own problems I'd like you to try, both solving and graphing, and then we'll check back in on solving and graphing inequalities next time.